Hello, my name is Jim Heffernan. I'm professor of electronics engineering technology at Quinsigamond Community College, and I'm going to give you a demonstration today on how to use the tool coordinate system jogging to do something like picking up an object that's at a specific angle. What we're going to do in this program is we have the robot with a pneumatic gripper attached, and we want that gripper to come down, pick this peg up out of this hole, trace a shape, put it back in the top hole, go back to home, pick it up out of that hole, trace a different shape, and put it back into the angled hole again where it started. And it should be able to repeat that indefinitely. So one of the things about this program is getting the gripper at the correct angle so it can come straight down onto that peg, pull it straight out of the hole, and then be able to put it straight back in again. And this is where you're going to see that the tool coordinate jogging system is going to be very important. So one of the things about the tool coordinate jogging is that the motion of the robot is going to be relative to the tool, actually the tool center point. And so, for example, if in order to select tool jogging, I have to, I don't know if you can see this, probably not, but anyway, hit the coordinate button till it says tool. There it is. And when it's in that mode, if I jog in the positive Z direction, it's going to move straight down from the faceplate. If I rotate the gripper or the faceplate, and then I jog again in the positive Z direction, notice how it follows wherever the faceplate happens to be pointing is where it's going to jog. So let me rotate it back the other way. You can see I'll rotate it around like this. Okay, if I go now the positive Z direction, it goes according to where the faceplate is pointing. And then the X and Y directions are relative to the faceplate as well. So the Y is across. Let me slow it down a little bit. So the Y direction is going like back and forth like this. The X is out and back. But if I rotate the faceplate, what I'm essentially doing is changing where X is pointing. So now X is going this way, and Y is going this way. Now what we're going to see is when we're applying it to this program that when we're going to write, we're going to pick up this angled peg. What we need to do is get that angle just right, and once it's right, we're going to use that tool coordinate system to jog down onto the peg, pick it up, and come straight back, jog straight back. So that's what we're going to do next. So the key to this is going to be getting that angle correct. So we have that gripper at just the right angle, so it's going to come down. Now you might think you might be able to eyeball it and line it up with your eye, and you might be able to do that. But what I find is a much more reliable method is to actually measure the angle of this peg that's coming out of the hole. So I'm going to just draw a very light line on this. I've got a piece of manila paper which is nice and stiff, and what I'm going to do is bring it over and use a good old-fashioned protractor to measure that angle. So I'll do that next. So here's that line that I just drew, and I'm just going to extend it out using this ruler. So I have something that's large enough to measure with the protractor. And I'm just going to take the protractor, line up the, what would you call it? The origin? I don't know. What do you call that point? And I can see that it's pretty much exactly 30 degrees. So that is a 30-degree line. So that's the angle, remember, just pull this up here. That's the angle that the peg is sticking up out of that hole. So that's the angle that we want to use to come down onto it. So now, to get the robot gripper at that angle, I need to start the gripper off at an exactly straight position. So fortunately I have a home position stored on the in the robot. It's just called home, and the position is defined as a joint position. Every joint is 0 except for joint 5, which is 90. So that means the gripper, when I go to that position, the gripper is going to be pointing straight down 90 degrees, negative 90, and then all the other joints will be at 0. So let me get it to that point. I just do a shift move 2. Okay, and now the robot is exactly at that position. So what I want to do is actually start writing the program, and because I want to start recording some points here. So I'm going to go out to select, and I'm going to create a new program, and it's going to be called EE for Electronics Engineering, JH, those are my initials, and I'll just call it PegPick. And we'll go into edit. Now, before we get started on recording points, the first thing we have to do is to enter the 2 commands to set the user and tool frame. Now, because this fixture that we're working with is square and oriented toward the world frame, I'm going to start this program out in world frame. Then when we've picked the peg up and we want to go trace the shape, this shape in this template, whoops, you can't see it. Anyway, the shape template over here is at an angle and it's tilted so that that's going to be oriented toward a user frame, and I've been using user frame 3 for that. So let's start off with the commands to set the user and tool frame. The first frame I'm going to use is user frame 0, which is world frame. And for this entire program, I'm going to use tool frame 2. So I put in frames, set tool frame number to 2. You probably can't see what I'm doing because of the glare, but there are other labs that we've done where you can see the details using RoboGuide. It's a lot easier to see what's going on. Anyway, just so you can see what I've got so far. User frame 0, tool frame 2. Okay, now what I'm going to do is have it go to the home position. So first instruction is I'm just going to enter a point, and it basically recorded a point which is where it is right now, but I want to change that to the home position that I've got already defined, which is a position register point. So I change the position register, and I'm going to enter a 1. So what I had to do is cursor over to the point, press choice, and that allowed me to pick position register. So that's my starting point. So now what I want to do is I want to use the world jogging coordinate system. So I'm going to hit this button until it says world, and that's going to allow me to move in straight lines, and I want to jog it so it's close to this area. Maybe I'll jog it over here so it's kind of up above the peg that I'm going to pick up, but not really too close to it. And once I get it there, then I'm going to adjust the angle so that it's at that angle, and that 30-degree angle that we measured is going to be key when we get to that point. So first thing I'm going to do is, so we're in world jogging, so I'm going to come straight down in the Z direction. Speed up a little bit. and I'm going to come over in the negative Y direction. So notice that the gripper is staying at the straight down angle, which is what I want. I don't want that to move yet. Come over like this, maybe a little more down in Z, a little further over in X. Okay, and I think I'll record that point before I do anything else. Just shift point, and I just noticed that these 2 points are recording as linear. I really don't want linear movements yet. I don't need them, so those are going to be joint moves. This will be another joint move. Okay, now this is the point where I wanted to find a new point that's going to set that at the correct angle. So all I'm going to do is reteach the same point that it's at right now, which becomes point 2. I really need to get that to joint. Change that back to joint. Okay, and I'm going to go and manually edit the coordinates of point 2. So if I go in here, I cursor over to the point, I hit position, and I'm not worried about these points. These are my Cartesian location points, 402 millimeters in X, negative 108 in Y, negative 118 in Z. What I want to deal with is this one, the rotation around X, which is this yaw, this one that's designated by the W. That is the rotation about X. So you notice that it's at negative 180. Well, it turns out negative 180 is the same as positive 180. It means it's 180 degrees away from its zero position. So if that's negative 180 or positive 180, then the angle that I want it to be at, so if I use my right hand rule, positive rotation is this way, negative rotation is this way. So from 180 degrees, if I go to 150, it should go to the right angle. So what I'm going to just do is go and make that a see what happens if I do negative 150. What do you think about this? Put in a 150. Okay, done. Now, to check where that point actually is, I'm going to use this. I've got it in step mode, and I'm just going to step to that point from where it is. Okay. And it is rotating the correct way. Oh, okay. So that, if our measurements were correct, that gripper should be at the exact angle of that peg. All right, so I'm good. I've got a good point. So at this point, what I'm going to do is I'm going to pause the video and get up close to where it is and kind of go through the process of getting that gripper into the right position.